in the future. Okay. Please note that going forward there is going to be a better version of this virtual environment, so that we don't have to wait for Azure to catch up. One of the ITS people here at the college, well, at the college, I'm not at the college right now, but one of the ITS people at the college has found a way of getting a lot more performance out of the virtual environment. It's going to be a little different, but once we're set up, I'm going to switch over to that, and it's going to be a lot quicker. So, log in to Kali. And you should auto log into Remnux, but if not, the username is Remnux and the password is malware. Okay. Once you have these two set up, there's going to be a little bit of some tweaking going on with your activities. Okay. First off, sorry, I have a headache. 1 second. First off, you have to verify your network settings in both environments to ensure that both of your machines are on the host-only network. And as we can see here, mine isn't. Okay. As we can see right here, my VM is not connecting. So I'm going to have to do something about that. Alright. I've got 2 adapters here. Let's see if I can't. Okay. I'm just going to quickly get this working. Okay, so I've got 2 adapters set up, 192.168.56.194 and 56.192. As I've said time and time again, you need to understand your environment, and this simply does not change now that we're doing malware. We have set up a toolkit, and again, you must understand your environment. Okay? Once we have our environment set up, we need to take a look at creating a virus. In the lecture area, I think this is it. Yeah, I have a document on how to create a sample virus using Kali. We've seen Kali in the past, okay? We've seen the tool that we're going to use in Kali in the past as well. And we're going to have to get into the habit of creating a directory structure that we can work with. The tool we're going to use to create our virus is called Msf Venom. Msf Venom is a payload tool that we used when we were doing shell attacks. And frankly, it didn't make the best payloads because, oh sorry, I shouldn't say payloads. It makes great payloads, but it doesn't necessarily make the best web shells that we used. It was great at generating them, there was no problem with that, but we had some pre-canned ones that we found much easier to use, as I'm sure you will recall. But that's not the only thing Msf Venom does. It'll also generate other kinds of payloads as well. And in this case, we're going to use it to generate viruses, okay? But again, we do need to have a proper workflow in place, okay? We are going to use Kali to create our first virus. I'm logged in as SJ. I should be able to do everything I need to do today as SJ, but if not, sudo is available, and you can always become root, because you should be able to become root. We'll talk about that another time. First thing I'm going to do is make a directory. Now we're going to take a look at the add user payload. Okay. So, I deleted all my old work. I created a new directory, making it a little easier for you to make out my work. And I'm going to work in here to create my malware. And it's pretty straightforward. We're going to use the Msf Venom tool, and we're going to generate a payload, which is the Windows add user. All right, it's the type of virus that will run through a series of commands to add a new user to the Windows system. We are creating a Windows executable. That's what the -f is. I meant to research what WMIC equals true. It has to do with permissions, I think. I can't recall what it is, but I apologize. I'll look into that. We'll talk about it later. Because we're doing the add user payload, we have to have a user and a password argument for this payload, just like we've seen with some of our other ones. Okay? And then the file type is an executable, and then we redirect that to something that looks like an exe file for Windows. So that's what we're going to type in at this point. Okay? Msf Venom -p Windows add user. User is equal to whatever user ID you want. Malware user. Give yourself a name that makes sense. Pass, because if we can detonate this in the future, you want to be able to see your work. And because we're going to try and detonate this virus in the future, not in the past. You don't detonate stuff in the past. You detonate it in the future. Because we're going to try and detonate this in the future, we want to make sure that it works. So we're going to use a valid password that's not going to be screened out. WMIC is equal to true, and then -f exe, and then redirect the results to malware add user.exe. I don't care what you call your executable. You can do whatever you want. It's entirely up to you. Okay? After a little while, you should get your prompt back. It'll look like it has a little bit of a complaint, but otherwise it should be okay. It's a very small payload. It's only 443 bytes. It doesn't need to be big because it's just doing a simple, and when we do an analysis later, you will see what it is. It does a very simple command execution. Okay? We do an ls-al, and we have created a malware. Okay? I'm going to ask you guys to go ahead and work on the rest of these. Okay? There's 2 more on slide 4, and then there's 1 more at the top of slide 5. Please work on those. Please do not run UPX. Frankly, it won't work for you until we install an update, so that's fine. Okay? So go ahead. The next one is Msf Venom. Well, you should be able to reuse a lot of that. Okay? We don't need that. We don't need the password. WMIC is equal to true is valid. And we're going to change our name from add user to shell bind, or bind shell. Shell bind TCP. Let's see if that works. Looks like it worked again. This time the payload's only 328 bytes, even smaller, and the same sized executable. And we'll see this happening because that happens a lot with these Windows executables. Okay? Go ahead and type in the other two commands at this time, please. I'll be back in a couple of minutes. Any questions on that? I'm not going to type them all in because really we're just trying to give you the basics of what we're looking for. Now that I have created my sample virus, there's some other things I want to show you about. With some of these, you know what, let's type them in. With some of these malwares, you can actually manipulate some of the parameters. For example, shellbind TCP will take another port. And you should see this looking very familiar to what we saw when we were looking at MSF console. Let's just do that, why not? And also, when you're taking a look at some of these things, it will do an encoding for you as well. It'll encode it, making it a little bit more difficult for hackers to take a look at. So I'm not going to type that one in. Let's talk about packing our code. There's a command called UPX, and when you type in UPX in Kali, yours is not going to work. because it's not installed. So what you need to do is sudo apt install upx, and then it'll ask for your password, and then it'll install the UPX utility for you. UPX is a packing utility for Unix, and what it does is it takes executables and makes them a little bit smaller. It also makes executables more difficult to do the analysis that we're going to do today. Okay? For example, if I wanted to, I could UPX malware add user and compact it into malware, -o I think. Yeah, -o malware add user underscore packed. Obviously you need to give the output a different file name. Okay? And it'll pack down the size of your executable. It makes it a little bit smaller. Any questions? Does that make sense? I have a red flag in Teams. No, sorry, I have to check something. Please give me 1 second, folks. Yes, is the recording, there is a recording going. If you want to record me, you can. I don't care if you guys record me, but there is a recording of this, and I will update it shortly. There's already one in place for what I did with the other group, though, so you should be able to see that as well if I'm not mistaken. If not, I'll fix that when I'm done talking. Okay? So, let's say, for argument's sake, that we're done creating our viruses, and we've deployed them. We're going to switch roles now. We are no longer the creators of malware. We are now the analyst. Somehow, we managed to get these malware on our, in this case, Kali box. I need to get them to my Remnux box. As always, as I said before, you want to create a workflow. So I'm going to do mkdir. Someone told me that the virus had the name add user to it. So I'm just going to call that workflow add user. Alright, so I can add my content to that folder. You can also do this when we're downloading it as well. Now I need to get my files off of this machine and onto my target machine. And there's a number of ways of doing this. Both Remnux and Kali have an instance of Secure Shell available and configured. All you need to do is turn on the service. We could do that, but we've seen an even more basic way of doing it. Does anybody remember how we used to get files off of a machine? Specifically how we got stuff off of Kali in the past? Real easy. Anybody remember? Exactly. Why don't we do that again? Yes, exactly what I was looking for. One, thank you. Why don't we do that again? Python -m, and then it's simple HTTP server, and it will take a default port, and it'll tell us what that default port is when we execute it. We must be in the directory that we want to download our files from, because that becomes the document root for this simple web server. Also note, the default port is different than what you normally see for websites because you don't know if this machine is already running a website. So you give yourself a different default port. Okay? We know what the IP address for this machine is. We saw it before. Or maybe I don't. Let's open up a new tab. IP adder. My IP address is 194. Okay, so that's the IP address I'm going to connect to through Remnux because I want to download to my install environment. So I launch a browser, and Remnux comes with Firefox built in. And I go to, well, that's just anticlimactical, isn't it? Type in the IP address, and you will see that I get a different list of files here. Obviously, I recreated a lot of the files I had last time, but this one's named differently, so it's not available. And that's it. That's one of the easier ways of getting something off of one machine and onto another one, is to simply use the Python simple HTTP server module. Creates a very basic website that we can then navigate to and download our content. When it comes to downloading this, you don't just click and save. What I want you to get into the habit of is right click and save link as, because we're all using Remnux, we're all using the same default browser, which is a Firefox, and we're going to save link as, and it's going to say, where do you want to save it? Go to your home directory, go to the directory you created before, or if you want, you can create a new directory. There's a create folder option available in Firefox. We've already created our directory, and we are going to save our file in that directory. And we can do that with all the files. Save link as, save, bind shell, save link as, save, and then finally our bind shell with a different port. Save link as and save. That way we're not just throwing it in the downloads directory, which is what normally happens when you download something with Firefox. We're putting it into a specific directory to maintain that workflow, which I cannot emphasize enough is critically important when it comes to dealing with malware. Okay? Right now in this class and in going forward in this class, we're not going to be touching anything too dangerous. We will be touching real viruses. These are real viruses. They are very innocent viruses. They're not going to do a lot of damage, and they'll probably be discovered very, very quickly. However, these are real viruses, and we need to develop a workflow around that now, so that becomes your default going forward. Any questions? Alright, I'm almost done. My head is screaming, so I'm going to wrap this up real soon. There's a couple of different commands that are available to you. Hex dump, and we could take a look at the add user malware add user.exe file. And what it does is it just dumps out the contents of your file in simple hexadecimal characters. Well, and I don't know about you, but I'm not that good at reading these things. Now, fortunately, the default configuration of this text editor already has 10,000 lines, and that's probably enough for what we're going to do for this analysis. You don't want, you can up that to 100,000 lines if you want. Again, edit preferences, scrolling, you can up that to 100,000 if you want, but you got to be careful because at some point it's just too much. Okay. Also, I can't read hex. I can if I have to, but I don't like trying to translate these things. So we're going to convert it to ASCII. So the first command we're going to take a look at is hex dump dash uppercase C, and then our malware underscore add user.exe file. And when we do that, it'll actually do a hex dump, but it will also give me some ASCII representation as well. And we can scroll through and try and find what's going on here. Okay? And it is long and tedious. It is a long and tedious process. I don't recommend this, but I want you to get into this habit of scrolling through and trying to find out what's going on, because just like pen testing, we're looking for clues. We're looking for things that are not typical. Okay? And I have found something that is not typical. I've got this command.exe embedded in a Windows executable, which iterates through some kind of a record and does a net user malware. It's doing an add statement of this username with this, malware username and password. So this block here is suspicious. When I'm writing a report, I might draw attention to that. Okay? And this is a good utility, but again, it's rare that this will work. There's other utilities as well. There's a tool called vbindiff, and we're going to look at malware add user again. It gives us a lot of the same information, but we can scroll down from the top now. And we can actually use the page up and page down. It's a little easier utility to scroll through. Now, after showing you this, your first question should be, well, why did I show you the other one? Because when it comes to these activities, time and time again, you're going to see there's many different ways of solving the same problem. Okay? vbindiff gives me the same information that hexdump gives me with the -C switch, in that it gives me the hexadecimal dump, plus it gives me an ASCII translation of that hexa information, plus it gives me a nice user interface that allows me to scroll through. When I'm writing the report on this, I can then highlight this content and say, I think this is problematic. Are there any questions? Does that make sense? Okay. I'm basically done. I apologize. I'm basically done. My head is screaming. You guys know I get headaches. I had them last semester. I'm sorry that I'm doing this to you. I'm going to stop recording now because nobody had any questions.